Okay, so this is slide 14. And previously, we looked at the number of valence electrons that different atoms had. And we said, okay, metals are going to lose all their valence electrons to become stable. Non-metals are going to gain however many electrons they need to get 8 to become stable. And as long as the total number of electrons lost is equal to the number gained, we're good. And so we figured out what the formulas would be based on the transfer of electrons. Today, we're going to talk about how we can do this with just the charges. So remember, an ion is formed when an atom gains or loses electrons. And the charge is always the number of protons in the nucleus minus the number of electrons. So there is an ion chart in the page in Canvas that is sort of the cover for Unit 4. That front page has an ion chart. So you just have to click on it and it shows you the ions. Of course, you can also use a periodic table because you know what the charges are based on the periodic table. So here's what we do. Let's say we want to write the formula for a compound between sodium and sulfur. So we're going to look up their charges on our periodic table or on our ion chart. And sodium has a +1 charge and sulfur has a -2 charge. Now, we know that in ionic compounds, all of the charges have to cancel out. So for the compound, the overall charge of the compound is going to be 0. So we have to think, how many of each of these do we need in order for the charges to cancel out?
2 sodium and 1
sulfur.
Sulfur.
Good.
Sulfur.
2 sodiums and 1 sulfur. So we write it like this. The 2 is a subscript. It says that I need 2 sodium ions for every 1 sulfur ion. And of course, the reason why we do this is because we want the total number of charges to add up to 0. So we've got 2 sodiums with +1 charges here. So these are my sodiums, +1, +1. And we've got 1 sulfur, -2. And when we add those all up together, we get 0. Okay? Now, to name this one, the other day, we talked about that in formulas and names, the metal always comes first. So we named the first element. So this is sodium. And then the second element is sulfur. But remember, we're going to change the ending to IDE.
Sodium sulfide.
So it's sodium sulfide is the name of this compound. And so that's how we're going to go about naming compounds using just an ion chart, not the valence electrons. All right, so here's example 6. So we're going to do a compound between calcium and fluorine. We're going to write in our charges. And then we're going to think, well, how many is it going to take for my charges to cancel out? So it's going to take 1 calcium and 2 fluorine. So here's my calcium. I have 1 calcium with a +2 charge, and I've got 2 fluorines. Each one has a -1 charge. And when I add those all up, I get 0. And so the name of this compound is, and my clicker's not working there. There we go, calcium fluoride. All right, so we're going to look at a formula between magnesium and oxygen. So we've got the symbols. We're going to write the charges.
between 1.
Plus 2 and minus 2. So, right, so it's going to be 1 to 1. It just takes one of each ion for the charges to cancel and make 0. And so this is going to be magnesium oxide. All right, one last example. So this is the compound between calcium and nitrogen. So we're going to look up the charges. We're going to use either our periodic table or the ion chart. And we're going to put our charges in. And then we've got to think, well, how many of each of these will it take for all the charges to cancel out? And so to do that, it's going to take 3 calciums and 2 nitrogens. So we can show that here. Each of the calciums is plus 2. So here's my 3 calciums. Here's my 2 nitrogens with a charge of -3. So it's +6 and -6. That's going to be equal to 0, right? So the name of this one is calcium nitride. Any questions about how to do that? Okay. So now I've got some practice ones to do here, but for some reason this keeps getting messed up. Let me fix this real quick. So we can do this together. There we go. All right. So in this table, all we're going to do is we're just going to basically fill in the columns. And so when you're writing the symbol for the cation, it has to have a charge on it. When you're writing the symbol for the anion, it has to have a charge on it. When we write the formula, there should not be any charges in the formula. There can be subscripts, but no charges. So for this first one, our cation is potassium, our anion is chloride, KCl is the formula, and the name is potassium chloride. Okay? So the second one, it gives us our formula, CaS. And so what we've got here, this has got the calcium ion with a +2 charge, and the sulfide ion with a -2 charge. And so the name of this is calcium sulfide. So the next example gives us the 2 ions. And so to write the formula, remember we need to figure out how many of each we need in order to have the overall charge for the compound to be 0. And we did one that was kind of like this with calcium and nitrogen. So we're going to need 3 calciums and 2 phosphorus to give our compound an overall 0 charge. And the name of this one is calcium phosphide. Any questions so far? Are we doing okay? Right. So the next one that gives us the name. So the name is aluminum fluoride. So we're going to go ahead and look at our ion chart or look at our periodic table, and aluminum has a +3 charge. Fluoride has a -1 charge. And so then we need to think about how many of each we need for the charges to cancel, and we get AlF3. Okay, the next one is lithium bromide, LiBr. It's made up of the lithium ion with a +1 charge, the bromide ion with a -1 charge. Okay, so magnesium oxide is the next one. We need to figure out what the ions are and what the formula will look like. So magnesium has a +2 charge. Oxide has a -2 charge. And so it's going to take one of each ion. So notice when we have one of each, we don't put any ones as subscripts. We just leave it blank. So if there's no subscript after the symbol, it automatically means 1. We only have to put subscripts for more than 1. So calcium nitride, calcium has a +2 charge, nitride has a -3 charge, and so it's Ca3N2. Thank you. So a couple of things to notice. And remember, ions have a charge, and it's written as a superscript. It's written up high. Formulas for compounds do not have any charges. There's no superscripts. There's only subscripts. And remember, those subscripts tell me how many I need for each of the ions in order to get an overall 0 charge in the compound. Okay, so this means that I need 3 calciums and 2 nitrogens. That's going to be 0. Okay, that's what my formula means, right? Any questions about those? Oh.